Hello friends, welcome to my YouTube channel. Now, I would like to discuss the APPSC Government Polytechnic Lectures 2013 Paper 2 and welcome to the Solutions Part 03 here. The first question here it is the Coulombs Law states that the force F between the 2 point charges Q1 Q2 is. So, if you listen the Coulombs law, it says that the magnitude of the electrostatic force between the 2 point charges is directly proportional to the product of the charges Q1, Q2 and inversely proportional to the square of the distance between them. So from this we can write it as F is equal to K into Q1 Q2 divided by distance is a R square. So this is the formula here. So from that the all of the above is the right option for this question. Next question. The next question is the total electric flux through any closed surface is equal to the total charge enclosed that surface is. So generally it is given by Gauss law. So what it says is the electric flux passing through any closed surface here uh, called as Gaussian surface is equal to the total charge enclosed by that surface. So total charge enclosed by that surface, it is nothing but it's a Gauss law. So Coulombs law we already studied about it, and next we will see the uniqueness theorem. What it says, uniqueness theorem, it says that for a large class of boundary conditions the equation may have many solutions, but the gradient of every solution is the same. Okay, so that's the uniqueness theorem here. And similarly Biot-Savart's law, what Biot-Savart's law says is the magnetic field intensity dH is proportional to the current carrying by the element IDL into sine theta divided by R square. So none of this theorem matches with the question, so it is only Gauss law. Next question. The next question here it is the electric flux density is also known as. So electric flux density is given by letter D, so which is nothing but electric flux divided by area. The units are flux per meter square. So similarly electrical displacements also having the same units as that of electric flux density, so both are same. So the electric flux density is also known as electrical displacements. Electrical potential means it's a voltage. Conduction current density means amperes per meter, okay, meter square, and none of the above. So answer here it is electrical displacement. And the next question is the line integral of the tangential component of H around a closed path is same as the net current enclosed by that path. So this law is referred to this Ampere's law. What it says is integral of the vector magnitude of field intensity H around the closed path is equal to the total current enclosed inside the path. So integral of H into dl is nothing but I. So this is nothing but Ampere's law. So answer here it is Ampere's law. Next question. Next question. In a traveling electromagnetic waves, the E and H, that is magnetic field intensity and electrical field intensity, vector fields are how they are. So as you can see in the figure, okay, the direction in three-dimensional. If you see here, so this is our electrical field like this. It is in downwards. So automatically the magnetic field will be in upwards. That means it will have, suppose this is the magnetic field intensity. Okay, so magnetic field intensity may be written as like this. So it is H and electric field intensity is E. So the angle between these two is 90 degrees. So 90 degrees means they are perpendicular in space. Next question. The next question is skin depth is proportional to. So the formula for the skin depth is written here. Skin depth delta is equal to 1 by square root of 1 by sigma pi mu naught into mu r into frequency. So from this skin depth is inversely proportional to square root of frequency and inversely proportional to square root of permeability and inversely proportional to square root of conductivity sigma. So square root of sigma is the answer here. Next question. The next question here is a problem. A 25-meter long rod. So 25-meter, a long rod is there. So its length is 25 meter. So the centimeter, let me correct, 25 centimeter long rod is there with a cross section of how much it is, 10 centimeter, is uniformly magnetized, has a pole strength of how much pole strength? H is equal to 120 amperes per meter. Determine the suitable value of current required for magnetically equivalent air core solenoid. Air core solenoid means, so here in between here we have air core. So air core solenoid of same size means it is same 25 centimeter length, okay, and 10 centimeters cross section area. So wound width here they given turns. How many turns? 1000 turns here, and here we will consider it as n is equal to only one turn here. So based on this formula, we can find here the current. So we know the basic formula is H is equal to Ni by L. If we consider N as a 1, then 120 into L into is how much? 25 into 10 power minus 2 is nothing but I. So if we solve this, I will be 30 amperes for this solenoid. But they given that the number of turns are 1000. So for the same magnetic field strength means I will take here also H as 120 amperes per meter is equal to N I by L here, right? So from this relationship what we can do it is, so we can for the same length now, so we can write it as N1 I1 is equal to N2 I2. So N1 is in the first one, amperes is 30 is equal to 1000 N2, okay, and I2 here the current. Now here the lengths are same, that's why I made this conclusion here. So don't confuse here. So I made a conclusion because of same magnetic field strength. So based on this formula I made the conclusion here. So from this I2 is equal to 30, okay, so it is going to be 30 milliamperes. So answer is none of the above is the right answer for this question. Next question. Hysteresis in an instrument means, generally hysteresis in an instrument means the change in same reading when the first input is increased. First we will increase the input like this and we will take the reading, and similarly when we decrease the input, again we will check the reading here. So that means hysteresis in instrument means the change in same reading when the input is first increased and then it is decreased, then what is the value of here, okay, it is an error, we can call as a hysteresis error, right? Next question. The torque by weight ratio of an instrument indicates what it indicates. First we'll see what is selectivity. Selectivity means it is nothing but it is a range of values or parameters, okay, so it is not there. Accuracy means closeness to true value, so closeness to true value. And fidelity means it is a degree to which the instrument system is capable of faithfully reproducing the same input when the change in output here, okay, so this is also not there. And sensitivity here, it is nothing but if the machine having torque by weight ratio is more, means the torque is production is more, weight is less, so it indicates simply the sensitivity. The other definition for sensitivity is change in output divided by change in input. So the torque by weight ratio of an instrument indicates its sensitivity. Next question. To measure 5 volts, if one selects 0 to 100 volts range voltmeter, so which is accurate within plus or minus 1%, then the error in this measurement may be up to. So here the measurement they given, that is guaranteed accuracy error, it is plus or minus 1%. So for 100 volts it is say 1 volt. So this is the error 1 volt. Now when we are measuring the 5 volts, it will also give plus or minus 1 volt. That means the output of the meter may be, so plus 1 means it may be 6 volts or it may be 4 volts. Now the error, so error is nothing but error is equal to the measured value minus true value, okay, in terms of its true value. So if you want percentage means we'll multiply with 100 here. So the measured value you can take it as a 6 or you can take it as a 4. So let us take 6. So 6 actual true value is 5 divided by 5 into 100%. That means 1 by 5 into 100. It leads to 20% error here. So the answer for this question is 20%. So thank you friends. Thanks for watching my video. If you like my video, please subscribe and share and like. Thank you. Have a nice day.